Okay, so last class നമ്മൾ പഠിച്ചത് ഡെറിവേറ്റീവ്സിലെ കുറച്ച് ഇമ്പോർട്ടന്റ് കാണാതെ പഠിക്കേണ്ട ഡെറിവേറ്റീവ്സ് ആണ്. So next step one നമുക്ക് നോക്കേണ്ടത് we have to look about three rules that we have to use in derivatives. That is, first one is the chain rule, second one is the product rule, and third is the quotient rule. Okay, so these are the three rules that we have to study next: chain rule, product rule, and the last one is quotient rule. So first of all, I'll tell you what is chain rule. Okay, suppose there is a function f of x is equal to cos x, g of x is equal to x square. What is FOG? FOG will be cos x square. So this function cos x square is a combination or composition of two functions, right? It is a composition of two functions. So whenever you have composition of two or more functions, in that case we have to use the rule called as chain rule. Okay, so whenever you have composition of two or more functions, you have to use the rule called as chain rule. Okay, for example, we know the derivative, that is d by dx of cos x is how much? We know that it is minus sin x. D by dx of x square is how much? We know it is 2x. Now what will be the derivative d by dx of cos x square? So whenever you are asked to find the derivative of cos x square, what you have to do is you have to identify what is the outer function, what is the outer function, and what is the inner function. So what is the outer function? Cos is the outer function. What is the inner function? X square is the inner function. Right? Because we have cos covering x square, so cos is the outer one and x square is the inner one. So whenever you are using chain rule, what you have to use is you have to find the derivative of the outer function. So what is the outer function here? Cos. So what is its derivative? Its derivative will be minus sign. So cos derivative will be minus sign. And what is inside x, what is inside cos x square? So just write down that. So minus sign x square into, the answer is not over because you have an inner function. What is the inner function? X square. And what is the derivative of x square? We know the derivative of x square is how much? 2x. So what do you have to do? You have to multiply that derivative also. So what is the final answer? You can also write that as minus 2x sine x square. So you can write the answer like this also. Okay, so is chain rule clear? I'll give another example. Find derivative of d by dx of tan 2x plus 3 and the derivative of tan 2x plus 3. So how do you find the derivative of tan 2x plus 3? So what is the derivative of tan? We know the derivative of tan is sec square. So first of all, you have to write sec square 2x plus 3 into, what is the derivative of 2x? 2x in the derivative and the d by dx of 2x is how much? It is 2. So into 2 plus 3 the derivative on the zeros. Just put what? 2 here. So what is the final answer? The final answer will be 2 sec square 2x plus 3. 2 sec square 2x plus 3. Is that clear? Another example is sine of cos of e raised to x plus x raised to 3. You have to find the derivative of this function. Okay. So when you see that the first outer function is sine, then you have cos, then you have e raised to x plus x cube. So first of all, what is the derivative of sine? Sine into derivative, we know it is cos. So what you have to write? Cos of cos x e raised to x plus x cube. So that is the first outer function sine. That's over. Now what is the derivative of cos? Cos derivative is minus sine. What is the inner function now? E raised to x plus x raised to 3. So cos is also over. Now what is e raised to x derivative? It is e raised to x. So put e raised to x plus, what is the derivative of x cube? Derivative of x cube is 3x square. So what is the final answer? This is the final answer. Is it clear? We don't need to simplify this answer. We just need to write like this. We don't need to simplify. Don't simplify. We just need to write the answer like this. Clear? Next, we are going to study about product rule. So what does product rule do? For example, we have a function like this, sin x into cos x. So when you are having a function sin x into cos x, is it a product of two different functions, sin x and cos x? Yes. Another example, I'll write e raised to x into log x. This is also another product, right? Because it is having e raised to x and log x as product. So whenever we are having two functions which are multiplied together, you need to use a particular rule to find out the derivative. So I'll just write down the two functions as u and v. So let the two functions be what? U and v. So how will you find the derivative of u into v? To find the derivative of u into v, you have to take derivative of u d by, sorry, you can do like this, u into derivative of v plus v into derivative of u. Okay, or in other words, you can use first function, second function. So when you use first function, second function, how can you write? What is the derivative? First function into derivative of second function plus second function into derivative of first function. So you can do like this. Okay, so this is the rule. D by dx of u into v is u into derivative of v plus v into derivative of u. First function into derivative of second function plus second function into derivative of first function. So we'll look at the two examples that we have written here. First one is find the derivative of d by dx of sin x into cos x. So this is the first function, this is the second function. So what is the derivative? First function sin x into, what is the derivative of second function? Minus sin x plus, what is the second function? Cos x into, what is the derivative of first function? Sin x into derivative and the cos x. So what do you get? Minus sin x into minus sin x is minus sin square x plus cos x into cos x is cos square x. So you can write like this, cos square x minus sin square x, or you can also write that as an identity, cos square x minus sin square x is what? Cos 2x. So you can write the answer like this also. Okay, so that is the first example. Second example that we have is find the derivative of e raised to x into log x. E raised to x into, so how do we find the derivative of e raised to x into log x? First function e raised to x plus into, what is the derivative of log x? 1 by x plus log x into, what is the derivative of e raised to x? E raised to x. So what is the answer? E raised to x into 1 by x plus log x into e raised to x. Is that part clear? Okay. So next is quotient rule. So now you understood product rule, so it will be easy for you to understand what is quotient rule. So when we have to use quotient rule, when you have two functions which have divided each other, right? So suppose you have a function of this form u by v. You have a function of which form? U by v. So whenever you are asked to find the derivative of u by v form, the rule is denominator. What is the denominator? V into derivative of numerator minus u, numerator into derivative of denominator, divide the whole divided by denominator square. Okay, so I'll use numerator and denominator. So how will you use that numerator by denominator? So denominator into derivative of numerator minus numerator into derivative of denominator by denominator square. Okay, so is that clear? So you have a function like this. I'll do an example here. Find the derivative d by dx of e raised to x by tan x. So you have to find the derivative of what? E raised to x by tan x. So how will you do that? Denominator tan x into, what is the derivative of numerator? E raised to x minus numerator e raised to x into, what is the derivative of tan x? Denominator derivative sec square x. The whole divided by denominator square. So what is the denominator? Tan x, right? Find the square and the tan square x. Now can you can take e raised to x common, right? So e raised to x common, and what you can write? Tan x minus sec square x, the whole divided by tan square x. So you have the answer e raised to x into tan x minus sec square x, the whole divided by tan square x. Okay, so this is the one example for quotient rule. So understood what is quotient rule? Okay. So in questions, when you're doing exercise questions or other exam questions, you will not have chain rule questions, product rule questions, quotient rule questions alone. You'll be having a combination of all these three. That is chain rule, product rule, or quotient rule. So you'll be having combinations of either chain or product or chain or quotient also. So look for those type of questions and try to do it accordingly. Okay. So in exercise 5.2, exercise 5.2, these are the first three questions in that. So what is the derivative of first question? Sine square x plus y. So d by dx of sine square x plus y la sine x square plus y. So you can see that it is of which form? It is of chain rule. So chain rule applicable sine into derivative and cos x square plus 5 into what is the derivative x square? 2x plus 5 into derivative. Since 5 is a constant, its derivative. Derivative of a constant is always what? Is 0. Constant derivative is always 0. Okay, so 2x plus 0 or simply 2x. So we can write the answer as what? 2x cos x square plus 5. So that is a question number 1. Second question, d by dx of cos of sin x. So again, it is chain rule. So cos of sin x means what? Cos into derivative and then a minus sin. So minus sin x into what is the inner function sin x? What is the derivative of sin x? It is cos x. So the answer is minus sin x into cos x. Third question, derivative of sin ax plus b. Again, it is chain rule. So sin derivative is what? Cos. So cos ax plus b into what is the derivative of ax? Ax in the derivative and then a. So into a plus b in the derivative is 0. So what is the answer? A cos ax plus b. So what is the answer? It is a cos ax plus. The next question number 4 is sec tan root x. So what is the derivative of sec tan root x? D by dx of sec tan root x. Okay. So sec is the outer function. What is the derivative of sec x? Sec x derivative is sec x tan x, right? So what do you have to write? What is the derivative? Instead of x, what do you have? Tan root x. So you have to write like this. What is the derivative of sec tan root x? It is sec tan root x into tan root x. That is the first part, sec x into. Next you have tan inside, right? So tan the derivative is sec square and you have root x into what is the left here? Root x. What is the derivative of root x? Root x in the derivative and the root x means x raised to 1 by 2, right? So what is the derivative of x raised to 1 by 2? It is 1 by 2 x raised to minus 1 by 2. What is the derivative? 1 by 2 x raised to minus 1 by 2. What is that? 1 by 2 root x. So what do you have to write? What is the derivative of root x? 1 by 2 root x. So this is the answer for question number 4. Sec tan root x into tan root x into sec square root x into 1 by 2 root x. Question number 4. Clear? And the next is question number 5. It's an important question. Sin ax plus b by cos cx plus d by division. So divisions mean which rule you have to apply. So division, I'm just erasing the question number 4 answer here, okay, because there won't be space to write. So here you can see that it is a quotient or division here, sin ax plus b by cos cx plus b. But as even though you are applying quotient rule, there is chain rule inside sin, right? Inside sin, there you have to use chain rule. Inside cos also you have to use chain rule. So this question you have to do in which way? You have to use quotient rule. So quotient rule, how to find the derivative using quotient rule? Denominator into what is the derivative of numerator? What is the derivative of sin ax plus b? Use chain rule. What is the derivative of sin ax plus b? Cos ax plus b into ax plus b the derivative and then a. So that is the first part minus. What is the numerator? Sin ax plus b into what is the derivative of denominator? Denominator derivative is minus sin cx plus d into c. Minus sin cx plus d into. So that is the denominator. Sorry, but that is the second part of the numerator. Divided by denominator square is what? Cos square cx plus d. So it's clear. So what do we got here? A cos cx plus d into cos. You can just combine all these and write together. So a cos cx plus d into cos ax plus b. There are two negatives, right? So two negatives will make it positive. So what do you get? Plus c into sin ax plus b into sin cx plus d, the whole divided by cos square cx plus d. So is the answer clear? Question number 5. So it is using quotient rule, but along with quotient rule, there is chain rule inside. Inside that numerator and denominator, you have chain rule also to be used. So use the chain rule appropriately and find out the correct answer. Okay, so that's question number 5. I'm just raising question number 5 because there is no space to write question number 6. So question number 6, just look at question number 6. When you look at question number 6, you can see that it is cos x cube into sin square x raised to 5. So what is it? Cos x cube into sin square x raised to 5. So here it is actually product rule. So product rule, first function is this one, second function is this one. So what about product rule? Product rule എന്ന് പറയുമ്പോൾ എങ്ങനെയാ യൂസ് ചെയ്യണേ? First function into what is the derivative of second function? This is a very good complex, a little bit complex question also. Okay. So before doing this question, just look at what is the derivative of sin x. You know the derivative of sin x is cos x. You know the derivative of sin x is cos x. But what about the derivative of sin square x? What about the derivative of sin square x? What is the derivative of sin square x? Sin square x is also a combination of two functions. Sin square x is also a combination of two functions. Sin x and x square. But sin x and x square combined will give you sin square x, sin x square, right? We have to get sin square x here. So sin square x is x square and sin x. X square and sin x will give you what combination? Sin square x. Okay. So what is sin x and x square? Adinte combination sin x square aanu, but x square and sin x. Adinte combination endana? Sin square x. So here you have to use that concept and use that to find out the derivative of sin square x. So the outer function is x square. So what is outer function? X square. Inner function sin x. Outer function x square and derivative is 2x. So outer function sin square x is 2x in 2 sin x into. What is the inner function sin x? Yes, sin x in derivative is cos x. So 2 sin x cos x, or 2 sin x cos x can also be written as what? Sin 2x. So what is 2 sin x cos x? It is sin 2x. So is the derivative of sin square x sin 2x? Yes, about derivative of sin square x sin 2x. Okay. So now we can use that formula here also. That is first function cos x cube into what is the derivative of sin square x raised to 5? Sin 2x raised to 5. Sin 2x raised to 5. Because instead of x here, you have x raised to 5. You have to apply quotient rule also. Chain rule also. X raised to 5 into derivative and what is the derivative of x raised to 5? 5x raised to 4. So multiply that by how much? 5x raised to 4 plus what is the second function? Sin square x raised to 5 into what is the next one? Cos x cube. Cos x cube is simple. Cos in the derivative is minus sin. So minus sin x cube into x cube in the derivative is 3x square. So what is the final answer? This is the final answer. And if you can write that like simplified form or just leave it like this. Just leave it like this. Because you can only write like this. So just write the answer like this and finish. Clear? Okay, next question, 7th question, 2 root cot x square. So what is the derivative of 2 root cot x square? This is quite simple. So 2 into root cot x square means it is a combination of root x and cot x square. Sorry, root x and cot x square. Root x and cot x square root cot x square. So what is the derivative of root x? Question discuss what is the root of cos x? Root of x. Root of x is 1 by 2 root x. So 1 by 2 root x in a bracket root cot x square. So 1 by 2 root cot x square into What is the inner function? Cot ആണ്. Cotന്റെ derivative എന്താണ്? Minus cosec square. So minus cosec square x square into x square. And what is the derivative of x square? 2x. So what is it? Okay, can you cancel this 2 and 2? Yes. So final answer can be written like this. എന്താണ്? Minus 2x cosec square x square by root cot x square. By root cot x square. Clear? Question number 8. Simple ആണ്. Cos root x. Cos root x direct chain rule ആണ്. What is chain? What is the answer then? Cos in the derivative minus sine. So minus sine root x into root x in the derivative എന്താണ്? 1 by root x. So the answer is minus sine root x into 1 by root x. That's question number 8. Next is question number 9. You have to prove that the function f given by f of x is equal to modulus of x minus 1. That is x element of r. X element ആണ്. This symbol here it is I or something. X is element of r. X is a real number. And it is not differentiable at x is equal to 1. You need to prove that this function is not differentiable at x is equal to 1. Okay. So look here. നമുക്ക് ഡിഫറൻഷ്യബിൾ ആണോ അല്ലെന്ന് പ്രൂവ് ചെയ്യാൻ നേരത്തെ നമ്മൾ നേരെ പോകുന്നത് LHD and RSD എടുക്കാൻ അല്ലെ. ലെഫ്റ്റ് ഹാൻഡ് ഡെറിവേറ്റീവും റൈറ്റ് ഹാൻഡ് ഡെറിവേറ്റീവും എടുക്കാൻ. പക്ഷെ അത് വേണ്ട. We don't need that here. So ഇവിടെ ഈ ക്വസ്റ്റ്യനിൽ നമ്മൾ ചെയ്യേണ്ടത് എന്താണ്? We just need to use another principle, that is, just look here. If f is continuous, if a function f is continuous, then only it is derivable. Then only it is derivable. Okay. ഒരു ഫംഗ്ഷൻ കണ്ടിന്യൂസ് ആണെങ്കിൽ മാത്രമേ നമുക്ക് എന്ത് ചെയ്യാൻ പറ്റത്തുള്ളൂ? അതിനെ ഡിഫറൻഷിയേറ്റ് ചെയ്യാൻ പറ്റത്തുള്ളൂ. So first we need to check differentiability here. No, we just need to check what? Continuity. So if the function is continuous, then only we need to check for differentiability, right? So just check for what here? Continuity. So when we are checking for continuity, what is f of x? F of x is equal to x minus 1. X minus 1 എന്ന് പറയുമ്പോൾ എന്താണ്? Sorry, modulus of x minus 1. Modulus of x minus 1 എന്ന് പറയുമ്പോഴത്തേക്കും it will have different values. It will have different values. Just draw the graph for modulus of x minus. Modulus of x minus 1 graph എന്ന് പറയുമ്പോൾ ഇവിടെ. Okay. It will be like here, like this. അപ്പോൾ നോക്കുകയാണെങ്കിൽ this point is 1 here. So to the right of 1, you have a line here. To the left of 1, you have another line here. അല്ലേ? അപ്പോൾ ഇങ്ങനെ രണ്ട് ഡിഫറെന്റ് ലൈൻസ് ആണ് റൈറ്റിലും ലെഫ്റ്റിലും ഉള്ളത്. അപ്പോൾ അതുകൊണ്ട് the mod x minus 1 function has to be written like that also. So to the left of 1, so for the values left of 1 or lesser than 1, what is the function? Mod of x minus 1 ന് പകരം നമ്മൾ എങ്ങനെ എഴുതണ്ടേ? Minus x minus 1 when x less than 1. Okay, minus x minus 1 when x less than 1. And next one is x minus 1 when x is greater than or equal to. So when x is greater than or equal to 1 എന്താണത്? X minus 1 ആണ്. മനസ്സിലായോ? So this is how you are right. Now we will just check for LHL and RHL. LHL and RHL. So what is LHL? Limit extends to 1 minus f of x. That is limit extends to 0 f of 1 minus h. That is limit h tends to 0 minus 1 minus h minus 1. So cancel. And what do you get? You get 0. For LHL, what do you get? 0. Similarly, RHL. RHL is limit h tends to 0 f of 1 plus h. So when you apply there, what do you get? 1 plus h minus 1. So they get, again, you are getting 0. So LHL, RHL is 0. And just find f of 1 also. F of 1 is also what? 1 minus 1. That is also 0. So the function is continuous, right? So the function is. Yes, there is a small mistake in what I have told. If I limits, continuity continuous. We need to use differentiability itself. Okay, so just take derivative LHD and RHD. Time waste. Sorry, just take LHD and RHD. So what is LHD formula? Limit. What is LHD formula? Limit h tends to 0. F of 1 plus h minus f of 1 by h. This is LHD. And what is RHD? Limit h tends to 0. f of 1 minus h, oh sorry, 1 minus h. LHD is 1 minus h by minus f of 1 by minus h. This is 1 plus h minus f of 1 by h. So what is LHD? Conducible limit h is 0. F of 1 minus h 1 minus h mod of 1 minus h minus 1 minus f of 1 1 minus 1 by minus h. So what do you get? 1 minus 1 0 minus h in a modulus h. So h minus this is 0. So h minus 0 0 h minus 0 h by minus h. So h by minus h LHD negative. RSD the limit h tends to 0. F of 1 plus h 1 plus h minus 1 modulus of 1 plus h minus 1 minus f of 1 1 minus 1 by h. So these two gets cancelled. So what is left with? You are left with a h minus 0 by h. That is 1. That is not minus 1, that is 1. So you have LHD, you have RHD. Both are not equal. LHD is not equal to RHD. So therefore, the function is not derivable. The function is not derivable at x is equal to 1. Clear? The next question, prove that the greatest integer function defined by f of x is equal to greatest integer function x is not differentiable at x is equal to 1 and x is equal to 2. So I'll just do at x is equal to 1 first. So at x is equal to 1, you have to find LHD. LHD at x is equal to 1. It will be LHD at x is equal to 1 will be limit h tends to 0 f of 1 minus h minus f of 1 by minus h. So that will be limit h tends to 0 f of 1 minus h greatest integer function 1 minus h minus f of 1 greatest integer function 1 by minus h. Okay. Now, what is 1 minus h? 1 minus h when you do 1 minus h. So when you do 1 minus h, 1 minus h, 1 minus h you are getting some value less than 1. So I suppose it is 0.98. So when you are doing greatest integer function on 0.98, what will be the result? It will be 0. So 1 minus h result, the numerator result 0 and minus 1 that is 1 itself by minus h. So minus 1 by minus h or it is 1 by h. When you apply the limit h is 0, what is 1 by 0? Infinity LA. Yes. So LHD is infinity. At x is equal to 1, LHD and infinity. Now we are going to find out RHD. That is limit h tends to 0 f of 1 plus h minus f of 1 by h. Okay. So when you apply that, what do you get? Limit h tends to 0 modulus of 1 plus h minus modulus of 1 by h. Modulus 1 plus h that is 1.01. So when you take the greatest integer function of 1.01, what will be the result? 1. So what do you get? Limit h tends to 0 1 minus 1 by h. 1 minus 1 is 0. So what is 0 divided by any number? 0 divided by any number is 0. So LHD and RHD, are they equal? No. LHD is infinity, RHD is 0. So LHD is not equal to RHD. Therefore, the function f is not differentiable at x is equal to 1. So x is equal to 1. Now you have to do for x is equal to 2. Okay. So for x is equal to 2, try to do it on yourself. This is exercise 3.2. എന്തെങ്കിലും ഡൗട്ട് ഉണ്ടെങ്കിൽ you can WhatsApp me. WhatsApp ചെയ്തിട്ട് ആ ഡൗട്ട് ഉള്ളത് ക്വസ്റ്റ്യൻ ഏതാണെന്നുള്ളത് ക്ലിയർ ചെയ്യാം കേട്ടോ. ഈവൻ ഈ ടെക്സ്റ്റ് ബുക്കിലെ ക്വസ്റ്റ്യൻ അല്ല, you can do other questions also from outside also and ask me doubts. Okay.